So hello, welcome back to my channel, and today we will have a closer look, take a closer look to the universal flight tablet. Especially I will focus on the performance calculations, because for advanced flight simmers or for those who are preparing for the real life operations, it will be crucial to make it within a proper way. So I will go directly through all the steps for the performance calculations, and imagine that we are flying from Rovaniemi to some airport. I put the Jersey airport or whatsoever, but anyway, so let's jump to it. First of all, I am missing here in Universal Flight Tablet the load sheet, and the load sheet is very crucial because we can see all the envelope, and in real life we would like to put as much as possible, for example, like cargo or checked baggage into the aft compartment, and I would like to know that if we are within the envelope or not. But yeah, we can use the load sheet directly from the FMC. So anyway, we have Rovaniemi Airport. Runway for departure 03, we have some elevations, runway length, we have condition dry, and I will omit this this runway conditions, and I will go straight ahead and import the weights from the airplane. Okay, I will import the weather as well, and now we can go back. Runway length, in real calculations you are using as well not the takeoff run available, but as well the takeoff distance available, because it really matters if you have runway safety area behind the runway threshold. You can increase in some circumstances your payload if you have larger takeoff distance available. But anyway, if you are using this, we are using the takeoff run available. If you have, for example, runway intersection, so you need to adjust it for your intersection, but we'll go through the full length. Runway conditions, this is something I would like to explain more deep in details. Okay, so we have a bunch of the options. We have dry runway, wet, standing water. If you have these few things like standing water / compacted snow, dry snow and wet ice are using if you have contaminations of runway, or let's say your runway is contaminated by some contaminant. Within the wet runway, you can use the wet runway, and the wet runway is considered to be contaminated when the thickness is more than 3 millimeters and runway surface is covered more than 25% of the contaminations. So right now in Rovaniemi we have icy contamination runway, but only 25% of the runway. So we'll consider this that the runway is not contaminated, that basically runway is dry. But if you have, for example, slush, in real electronic flight bag, you have to put as well the thickness of the contamination. So you have 2 millimeters, 3, 5 millimeters. For example, dry snow, this has affected your acceleration and deceleration as well. And you can have, for example, 5 centimeters of snow on the runway. So we have to specify, because if you have dry snow on the runway and it's less than 3 millimeters of water equivalent depth, I will put a table for you. In this case, we can consider the runway is not contaminated, because 3 millimeters of dry snow is not considered as the contamination of the runway. But anyway, if we go to the wet ice conditions, some operators are prohibited to perform any departure and landing on wet ice, but on dry ice it's allowed. In case your operator approved this kind of departures from wet ice or dry ice or compacted snow, it's crucial to have some chemical treatments of the runway. If there is loose sand applied to the runway, that means that we are no longer using wet ice or dry ice, but we are using the friction coefficient and we will specify what are the braking actions. So again, I'm missing here the friction coefficient because in real airplane and real electronic flight bag you have the availability to make it within this way. But remember, when you have contaminated runways, these kind of contaminates for the particular runway can decrease your maximum allowable performance limited takeoff mass by the thousands of kilograms. Okay, so for the time being I will put dry runway, and now you can see that we have weight 65.6. Yes, because he will take it directly from your FMC. But if you are performing the departure, for example, we have the taxi fuel to burn 200 kilograms. If you are performing de-icing, our takeoff weight will be again lower. So I will make it 65,400, okay? And now we have everything set, so we can calculate it. And as you can see, we have few options here. We have acceleration height here. Remember, if you are using NADP or you have specific company procedures, so this is no longer valid for you. It may valid if you are performing, for example, improved climb and you have delayed your flaps retraction. Okay, so this is your minimum acceleration height to be used for the departure. So that's what I'm missing here, because you can be limited within your takeoff mass. You can be limited by obstacle limited weight, climb limited weight, or field limit takeoff weight. There is brake energy as well, but I have never used it in real life. So if you are limited, for example, with obstacle and climb limited weight, you are performing the improved climb, and again the improved climb is missing here. So this acceleration height 1500 is just for your eyes here. Okay, so we have flap setting of 5, we have no derate, that means takeoff we have 26K, and we have selected temperature, or let's say assumed temperature. That's quite okay. That's perfectly fine because we are on dry runway. If I put the runway contaminations, it should be not authorized. Okay, so if I put, for example, compacted snow and recalculate it once again, as you can see, the assumed temperature is not authorized, so it is okay. The V speeds, I am really satisfied with this, because when you have contaminated runway or wet runway, your V1 will be, in most cases of scenarios, much lower than rotate. So I will put dry runway, recalculate it once again, and as you can see, we have 140, 141, and 145. But if we put the wet runway, the V speed will be different. As you can see, we have only 4 knots. Okay, if you put contaminated runway, so that means that the accelerated stop distance available will differ. So as you can see, we have 120, okay, because we have increased accelerated distance available for our departure. So basically, if we are using, for example, anti-ice or PAX, okay, so we are using PAX, air conditioning for departure, and we are using engine anti-ice. Regarding to wing anti-ice, this is quite a tricky situation, because if you on Boeing 737 press toggle button and you have wing anti-ice on, it will automatically trips off on real airplane. And you can find this, for example, our cockpit companion, which was made by Bill Balfour, technical pilot of Boeing 737. You can find this information right there, that if you press toggle button, your wing anti-ice will automatically trips off. Okay, so I will assume the engine anti-ice and we will recalculate it again. And we have now, as you can see, again flaps 5 and V speeds are nearly the same. What I would like to point out here right now is that in some circumstances, if you are using full takeoff thrust, you can take less payload comparing to using D-rate 1 or D-rate 2. It's because you have lower VMCG, and this is the special circumstances. Okay, so in sometime if your performance calculations doesn't allow you to perform the takeoff with actual takeoff weight, so you can go down with takeoff 1, try again with takeoff 1 and takeoff 2. But I think that this case scenario will not apply for this performance calculator. But in real life, sometimes the less thrust setting you have, if you are taking into account only D-rates, because only D-rates are available to use or short on contaminated runways. Okay, so if you press, for example, 22K engines, you can take much payload, but this is again for advanced performance calculations, because here this is just the simple calculation from my point of view, because I don't see here if we are field limited weight, if we are obstacle limited takeoff weight, or if we are climb limited takeoff weight. If we are climb limited, we can go to improved performance, and we have a lower flap setting, so we can use the flaps 1 only. Because if you are field limited takeoff weight, for example, you are flying from Skiathos, 1600 meters runway, so in this case I will use higher flap settings because we are field limit. Okay, so let's jump to the landing dispatch. Landing dispatch is something which we are using prior to departure, or if you are planning to, or let's say like this one, we are using landing dispatch for the flight planning purposes. What is it? So I will put the worst case scenario here. We can import some weather. We have flap setting, for example, 30, PAX on, anti-ice off. We can perform some calculations. And right now you can see that in this case, if you are flying to Jersey Airport, we are limited with the landing weight as 58 tons. And quick turnaround weight should be 84 tons. The quick turnaround is basically within the 30 minutes after landing if you are using the full reverse and maximum braking. Okay, so we can take this fuel because the brake energy limitations take or quick turnaround take into the consideration the weight and the brake cooling for your takeoff, and it will take into the consideration that you have rejected takeoff. Okay, so right now you can see that we should have for the landing 58 kilograms. Okay, so this is this should be within our landing calculations, so we can check it within your operational flight plan. What is your estimated landing weight on your arrival? If your estimated landing weight will be, for example, 62 tons, in this case I have to adjust my payload for departure, so I will not take 65, I will take only 63. So I will reduce my payload. So, for example, 180 passengers are not allowed in this case, so I will go and jump to the 150 passengers as my booking capacity of the airplane. So that was the explanation of the landing dispatch, and well, we'll jump to the landing en route once we are within the cruise. Okay. Okay guys, so we are now in cruise, and I will come a little bit back to landing dispatch. As we are flying to Jersey Airport, and we are limited with the weight 62 tons. So if I press, for example, flaps 40 and recalculate it, you can see that our weight with the flaps 40 should be 66.3, which is structural limit weight. Okay, so we have some landing distance available with the display threshold, and if I choose, for example, flaps 15, but you cannot make intentionally before your flight and make intentional that hey, we are going to use the flaps 15, because flaps 15 on 737 are using only in non-normal conditions. So if you put flaps 15, now you can see that we have much more lower performance limited takeoff weight at 57. So well, quick turnaround weight is the same, but as you can see, our performance limited landing weight, it's lower comparing when we are using for example flaps 40. In flaps 40 we are basically on structural limit weight, but imagine that in Jersey airport there is strong gusty conditions, so we cannot use flaps 40 intentionally, so we have to use flaps 30. So in this case we have to reduce our payload prior to departure in order to meet 62 tons in landing. So if I go here and we can check the operational flight plan, and as you can see the landing weight estimated will be 56. So if we go back to landing dispatch, you can see that we are okay even if we put much more payload on departure. So coming back to landing en route, and right now you can see we'll pre-select the runway, but I don't know what is the runway right now, so it will be 230 knots, so okay. So runway 21, this is the, sorry, this is the Rovaniemi. Right now Jersey, runway 26, runway condition is dry, and import the weather conditions, and right now well, if you just import airplane details, you will have the actual gross weight. So if you go here, you can see 66.2, and we are accounting with 66. So normally flight crew will start to prepare for the landing 80 nautical miles prior to top of descent. And the landing preparation, except if I omit all this stuff like FMC, auto brakes, MCP and now settings, one part is related here. So as you can see, we have 9.7 actual fuel on board, and on the landing we are expected to have 3.1. So we are going to burn approximately 4.6 tons of fuel, so you will need to adjust your gross weight. Okay, so 62 and 61.6. This will be our gross weight for landing, so we'll put flaps 30 as we have 20 knots of wind condition and plus 10 knots as the VREF additive. In this case, our approach speed will be 154. So you have to put this gross weight 61.6 as well here. Right here, and we'll leave, for example, auto brakes in this position, and all reversers are operative, and we have additive, we have 10 knots. So now we'll calculate it, and as you can see that this is our weight. Okay, we have some calculations. We have landing distance available and landing distance required. So right now you can see that well, this configuration is not possible for us. What we can do, we can adjust the auto brakes, for example, auto brakes 3. Remember, when you are using reversers and auto brakes, no matter how much reverse are you using, it will, when you have auto brakes operative, it will monitor your deceleration unless you put maximum braking. So we will recalculate it, and right now you can see the required distance is still not enough. So we have to go to max auto, and right now you can see that okay, our landing distance is quite okay for us. we have no non-normal conditions, and if you have, for example, engine failure, or you have hydraulic B pressure completely lost, so you can adjust it right here. So right now you can see that we match all the conditions. The weight should be the weight I put here, okay, because this is the structural limit weight. What I'm missing here is a go around climb gradient, because on some airports you have, for example, if you use or let's take it like this one. Let's pick up the Salzburg airport. In Salzburg airport you have higher climb gradient. So in this case we will see if our landing weight it's as well okay for the go around climb gradient. If no, we will adjust it, or let's say we can pick up higher minimums, or adjust it. For example, we are not using flaps 40 and we will use the flaps 30 instead. So this is regarding to go around climb gradient, but we don't have availability to see what is our go around climb gradient and to adjust this setting, so I will leave it like it is now. Okay, so this is the landing calculation so far, but anyway, in real life I am not using these calculations, because why? If you are performing the landing on long runway, auto brake 1. If the runway is wet, auto brake 2. If the runway is short or contaminated, auto brake 3 or auto brake max. If the wind condition is, for example, we have strong crosswind or gusty conditions, I will go for flaps 30. If there is still air conditions, we can use flaps 40 if the runway is too short. So that's the basic explanation for the common sense what auto brakes and what reversers I am using. So if you are planning to land at the short runway which is contaminated, and we have strong gusty conditions as well, but these gusty conditions, remember, should be within your limitations, and limitations on contaminated runway, for example for crosswind component, it's much more lower than for dry runway. It's no longer what you can see on the flight crew operation manual FCOM. You have to pick up it from your operation manual part B. So I think that this was just a quick explanation of performance within the PMDG flight tablet. So I hope you liked the video and see you next time soon. Have a safe flights. Bye.